This conference will now be recorded.
Hello, everybody. Happy 2024. You have joined us for the Satellite Book Club Seminar Series. This is the first session of the year, but the 173rd session overall. We've got a great presentation coming today. Tales from the Testbed, the 2023 Satellite Proving Ground HWT with Kevin Thiel, Research Meteorologist at CIWRO, and GOES-R Satellite Liaison to the Storm Prediction Center and NOAA's Hazardous Weather Testbed. Following Kevin's presentation, we'll have discussion facilitated by Ross Van Til, meteorologist from the National Weather Service, Office of the Chief Learning Officer. Before we dive into that, I just wanted to ask for your help if you're joining us from a field office today. If you don't know the answer to this question, please check with your ITO or SUE. Ask them if your office has installed the TowerS RPM v24. You can install the TowerS RPM version 24 without an appointment. This RPM has several capabilities, including the CIRA GeoColor and GLM 5-minute data. We've had great progress with 88 sites installing the RPM so far, and we'd like to get that goal to well over 100. The instructions can be found on the TowerS RPM VLab page, and there is a link in the chat. So please help us get all of the offices running TowerS RPM version 24 as part of your office's AWIPS. All right. With that, we'll dive into today's presentation. As you heard, this session is being recorded. As always, there will be an opportunity for Q&A after the presentation. Please post your questions in the chat and we'll field them in the order that they are asked. If you have signed in with an office account or have not noted your full name when signing in, please note your name when asking a question in the chat. That will help us follow up if necessary. And we're always looking for future presenters. Please contact our TowerS team, Kashad Bowman and Emily Maddox, if you would like to present. Perhaps you have a presentation for the upcoming AMS annual meeting. We'd love to have that presentation as part of the book club sometime this winter or spring. And the training team can help create training materials that may be unavailable or you may be unaware of. Ross Van Til, our facilitator today, can help with questions regarding that. So feel free to ask Ross about anything related to training as well. I'd like to thank our TowerS team, Kashad Bowman and Emily Maddox, the Office of the Chief Learning Officer, the GOES-R JPSS programs, our presenter, facilitator, and all of you for being with us today. All right, let's dive into the presentation. Kevin Thiel is a research meteorologist for the University of Oklahoma CIWRO, serving as the GOES-R Satellite Liaison for the Storm Prediction Center and NOAA's Hazardous Weather Testbed. He leads the Satellite Proving Ground HWT each spring and works with Storm Prediction Center forecasters to integrate satellite data into operations. Kevin is a PhD candidate for the University of Oklahoma School of Meteorology, studying operational applications for the GOES-R GLM. And we're glad to have Kevin back to the Satellite Book Club today. Kevin, take it away.
Thank you, Jordan, and then also thank you to Ross and to Kashad as well for hosting me today. And I'm excited to be the first presenter here in 2024. I wanted to call this presentation originally the Satellite Proving Ground Wrapped for 2023, but I figured just keeping it pretty plain and simple today, just the tales from this last year's testbed, talking about the main results and the key feedback that we got from our Satellite Proving Ground experiment in out here in Norman. So for those of you who aren't as familiar with the HWT, that's okay. The HWT is a really unique space within NOAA where we're able to bring together both the operations and the research sides, especially in terms of being able to test and evaluate these kind of new and emerging products and technologies for NWS operations. So we're bringing together the research community and the operational community within the same space. And we're able to share a lot of knowledge and tools and different perspectives that can then go into evaluating various products. Satellite Proving Ground experiment is just one of a number of experiments that occurs within the HWT each spring. There are a number of other experiments as well that focus on the different facets, but we focus on, of course, satellite data and how that can apply to hazardous weather forecasting. So our experiment this past year was 3 weeks in total. We featured 22 total forecasters. We cycled through about 7 to 8 each week. We had 1 week that was entirely in person and then 2 weeks that were entirely virtual. And this was the first time we had done an in-person week since 2019, which was really exciting. It also was a lot of work to pull together and kind of bring everything back, but it was well worth it, as we'll show. We look at live weather. So we go where the weather goes. We're looking at data in real time. So we don't know what's going to happen. The forecasters don't know, the developers don't know, and it presents a nice sense of operational realism, which is what we strive for within our testbed. Forecasters can do a number of things with their products within the testbed, everything from pre-CI to looking at mesoanalysis and looking at the environment from various fields, along with looking at information that relates to warnings or warning decisions, and then also ways in which to message for decision support service events, or DSS. This past year, we looked at 5 different products within the testbed and used those throughout the testbed, and we're able to have forecasters give feedback throughout at various stages. So one of the things I want to kind of briefly show here, since I have time in this kind of a talk versus what I maybe would have in an AMS talk, is how we actually are able to merge the research and the operations. So I kind of think of it as how we are able to researchize the operations and pull information from that. And we can do this through a number of means, but we try to make every step along the way a point where we're collecting data. So one of the most obvious ones is having discussions, talking with forecasters. We have discussions that you can see in our schedules here on the right side for the virtual and the in-person weeks. We have discussions built into basically every day where we're talking with forecasters, but this also happens as well during the times when we're also running in operations. When we want to collect more quantitative data, we'll use surveys. So we also do daily and weekly surveys. Forecasters can also journal their thoughts and provide really great use cases in blog posts as well. And those are available on the Experimental Warning Program's blog that we then are also able to pull from. Forecasters are then issuing warnings and also providing DSS messages, which are all logged in a Google form. We also have forecasters, they have the ability as well to make public graphics too, where they can take these data and attempt to communicate them, whether it's to the general public or to a partner, especially during a DSS event. So all of this to say, we try to collect data at every point, and the whole goal is to keep forecasters engaged and have them, even on days where we have more marginal weather, something that they can work on and do, but that the idea is that they don't have to feel overwhelmed with doing 5 different things at the same time. And so this is kind of this rolling feature that we're able to use to hopefully collect data at each step along the way that we've kind of curated over the last few years. So by the numbers, I just kind of want to show all of the different, or everything that we collected and everything that happened from the testbed. It's just kind of fun to look at all these different features here. The map here on the right shows all of the CWAs that we used, and when we were able to localize our cloud AWIPs too from each of the days. So we go where the weather goes. After having a forecast discussion, we break out into groups of 2 to 3 forecasters, and we assign them various CWAs throughout the CONUS. And we're then able to localize to those CWAs and then run our simulated operations from that. So we ran, along with using 27 different CWAs, we looked at where we had 26 simulated DSS events. We issued a number of messages and also a lot of warnings as well, nearly 100 warnings this year. We had 16 hours in total of group discussion, lots of hours of operations too. Because we were in person, we were able to up that number considerably. And then we collected a number of survey responses from the daily and weekly surveys too. This just shows everything that we kind of collected in a nice view here, which just shows how much we have going on throughout this year. And we will travel anywhere. As we can see, we traveled over to the Western region with Elko and Boise, but even all the way up to Albany as well. As long as we could get the cases in to do it, we try to hit as broad of a geographic spectrum as possible throughout the test bed. So I mentioned that we had 5 different products, and now I'm going to go through and talk about what those were and what we were looking for in those products throughout the test bed. The first one here we'll talk about is NUCAPS. We looked at the gridded NUCAPS and NUCAPS forecast. So with NUCAPS, that's the soundings that are collected from the NOAA 20 in low Earth orbit, and those temperature and moisture profiles have been able to be provided in a planar view there with gridded NUCAPS. Now, let's say you have that information and you want to think about, well, where are these values going to be an hour from now, 3 hours from now? That's where NUCAPS forecast comes in. It takes that information collected from the NUCAPS overpasses and then is able to advect that forward using the NOAA high split model, which is based out of the GFS profiles. And so that provides hourly information out to 12 hours for those features. And so they were looking at how that temporal and spatial information impacted a forecaster's view of the environment. The next one here is one that we tested for the very first time within the test bed this last year, is OCTANE speed and direction products. These products use the GOES mesoscale scenes and are able to provide very high temporal and spatial resolution of cloud top winds. And so those are then derived from an optical flow code developed by Jason Apke at CIWRO and built upon from previous iterations. And so this provides speed and directional products, especially looking for things like divergent signatures at cloud top. And so the key question out of these products were how they could be applied and their utility within these kind of severe convective scenarios. Continuing on, talking about next, we have the PHS model. PHS stands for the Polar Hyperspectral Soundings. Also included in this model are ABI information. So soundings that are collected from NOAA 20, NOAA 21, and then along with MEDOP B and C. Those are then integrated and also extended spatially and temporally by the GOES ABI. And are then used in a data assimilation scheme into a model or into a convective allowing model. So the idea is how these hyperspectral profiles can provide additional information within convection allowing models. And so there were a number of fields that were tested. They were expanded considerably from the previous year with additional model fields and also a new composite reflectivity product as well to help compare in a more real-time sense. Next, we have ProbSevere version 3. ProbSevere version 3 is an iteration and basically a whole new model architecture compared to ProbSevere version 2, which is currently operational. ProbSevere version 3 brings in multiple data sources from satellite and radar, and then also from NWP mesoscale fields as well, to then provide the probability of various hazards over the next hour. So ProbSevere version 3 has a different model architecture, providing different outputs. Additionally, this year, ProbSevere version 3 switched over to using her mesoscale analysis fields versus previously what was used was the RAP. And so the big question coming out of this was how forecasters would look at those data and how that maybe would impact their interpretation of the probabilities. Another ProbSevere product that we tested, coming back again for a second year, is the ProbSevere LightningCast model. Also a machine learning model, a different type of architecture used in that one as well. This machine learning model takes in 4 different satellite bands from the visible, near IR, and long wave IR frequencies, and then is able to produce the probability of lightning observed within the next hour. Its truth data set was trained on the GLM, and it provides these output in the CONUS and the mesoscale scenes. So it can be provided within those temporal and spatial frequencies. Its spatial frequencies is 10 kilometer, but we're able to provide that probabilities from both GOES East and from GOES West. New this year was the ProbSevere LightningCast time series, which was a web-based tool providing that information for a singular point in that time series format. And so there was a big question of how this maybe could help with DSS events. So now that I've went through the products and kind of given a quick spin up on what they mean, I'm going to go through and give them kind of the sense of, imagine your average convective day, what's going on as you have kind of that pre-CI environment, and then you have the initiation, and then monitoring that convection and communicating whether it's the DSS messaging or the warnings from there. So we'll be focusing now on the applications of these data. So when focusing on NUCAPS forecast and when looking at mesoanalysis, forecasters often compared these data with the SBC mesoanalysis along with NWP fields. Most commonly, lapse rates, especially in the low to mid levels, were used along with the CAPE fields and precipitable water, or PWAT. With the lapse rates, most often forecasters were encouraged to use especially the mid-level lapse rates, which is really where NUCAPS is able to have typically the highest accuracy and data quality. Now, speaking of data quality, the quality of the overpass does impact the utility of the data and how useful that data can be. So the example here on the right, there is an overpass from NUCAPS here that is provided to the forecaster, and they were looking at kind of the low to mid-level lapse rates and comparing them against the surface to 3 kilometer lapse rates from the SBC mesoanalysis, doing some verification of the product. And they showed that even though during the overpass there was convection, as we can see these kind of spurious points where these data points don't look as physical, they do then show up and reflect well when comparing against the SBC mesoanalysis lapse rates. Another question that was discussed about every week in the testbed was the optimal duration and the frequency in which forecasters receive these data. So in the testbed, forecasters receive these data hourly, out to 12 hours, and that provided that information then out into the future and provided then for the time for the next overpass then to come to create this temporal consistency. But forecasters responded that they felt that having data that was more frequent was a bigger priority to them, to be able to look at these rapidly changing fields, especially in convective environments, and would rather have the data out to 6 hours. In some cases, that could be just based on the amount of data coming in and what they would need based on their events. Additionally, over time, as you're vecting forward in time, because of things like as you're modifying things like your boundary layer due to surface heating and other different features, that you tend to then start losing that, you're sort of to decouple from the initial state of the observation, as it's being vected forward in time. And so that also then ensures data quality for those forecasters. The PHS model was also used for mesoanalysis, oftentimes again comparing with the SBC mesoanalysis along with various other cams and radar as well, especially when using that PHS composite reflectivity product and the base reflectivity product from various radars, depending on where the forecasters were. Instability, shear, and that reflectivity product were the most commonly used. Now, because this is a model looking at CI timing and location, and where those fields were was considered quite important for those forecasters, along with being able to ascertain their storm mode and evolution. And then also how well these models agreed with the other cams, and what information was being added from those polar hyperspectral soundings into this model. And forecasters expressed a desire to be able to understand the base state of the model and what was being adapted and changed based upon the information that was being assimilated from those soundings. And so that was available through a web viewer, but forecasters were looking for some other ways to also display that data. Now, once we get to initiating convection, that's where products such as OCTANE and LightningCast came in more often. And these products can both ascertain CI, but they approach that in different ways. When we're talking about OCTANE, we're talking, of course, about wind. So we're looking at more kinematic signals of CI. So when you have that strong deep layer shear, as you have the convection initiate, your cloud top ambient wind speeds are going to then increase. And so so you can see here in the bottom left-hand corner an animation of some CI here along a dry line on the Texas Panhandle. And so if we look at the colors of these returns here, what we're actually observing is the transition from the blues to the yellows and greens into the reds as the velocities that increase in those cases. Now with LightningCast, because we're looking at visible, near infrared, and long wave infrared imagery, we're looking more at the thermodynamic signatures, especially related to glaciation at cloud top. And so those are then picked up as well as we have those cooling cloud tops. And that's where we also then see the appearance of those percentile contours here. This is about a 20-minute loop here of some data from the GOES mesoscale scene, or from GOES East. And so we can see that just how rapidly these can evolve when we get eventually to that 75% probability here at the end of the loop. Their timing relative to radar was also noted by several forecasters, that as we looked at the satellite information coming in more frequently, especially in between or based upon what VCP that the radar was operating in, that timing, or that satellite information could lead that in a slight way as well. One thing to note about the LightningCast probabilities, and one caveat we found this past year and also the year before in 2022, was that when you have things like dense cirrus and overcast, that obscures the view, especially from the shortwave IR cases of where you're actually having the glaciation and that initiating convection. And so if more or less, if you can't see it, especially in something like the Descartes phase distinction product, LightningCast is also going to have a hard time observing that as well. And that was noted in this case here. And so there may be probabilities here, but they didn't exceed that 10% to then create the contours that a forecaster was in looking for in these cases. Now, once a storm's initiating and going, we then are looking at monitoring that convection with OCTANE. So leveraging those cloud top winds and also those divergent signals that then are observed from cloud tops. Most often, forecasters were encouraged to compare with various satellite imagery, radar, and then also with the GOES derived motion winds product as well. That produces, of course, very high quality observations, but they're fairly sparse in their spatial and temporal frequencies, especially with respect to convective evolution. And so forecasters latched onto those quite quickly to look at those kind of rapid changes in the cloud top winds from different cases. When looking at the cloud top winds and divergence signatures, you maybe haven't seen OCTANE all that much before, but in these cases here, maybe you can see my mouse here, if you can see that in the bottom left-hand corner, we're highlighting these two cells that had went up here in Nevada. And as they go up, you'll see then the initiation, and you'll see because of the divergence signature, a decrease in the wind speeds that are moving back against the overall background flow aloft. And so that then slows down those winds and creates this kind of diverging color signature, which is what you're actually looking at here. So you're seeing those winds that are slowing down behind that region of divergence. You can see that as well here in the a little bit further right from the kind of that larger apparent signature. We can see that also here. There's a supercell we can see here on the top right-hand corner. This was in southern Texas, just along the Mexico border. And so we have, again, that divergent signature with the westward component there that's being factored into the overall background flow and creating these slowing winds in those cases. We also can observe here a really interesting case of an above anvil cirrus plume with those slower winds among the faster background winds further off to the right. And this kind of plume region, that's as we have the ice that is injected then into the lower stratosphere, where then you have weaker winds. And so those motions can then be picked up with that overall plume. The direction product is featured here on the bottom right panel, and that can provide kind of the overall ambient directions, especially in cases of very strong divergence. You can then see multiple colors as the colors are then related to the direction here in the direction product. Now looking here, just underneath kind of that canopy here from the cirrus canopy from that supercell, we can see some the red colors down here. These are more related to the inflow as we have the southerly winds that are then feeding into the supercell. So even being able to understand or ascertain the mesoscale environment is also important there. Also with OCTANE, looking at its display is a little bit different from most products, leveraging more of the HSV or the hue saturation value color space, as opposed to maybe what you would think of previously with things like RGBs. This is not an RGB. but it uses some of the HSV display principles within these data. So forecasters had a number of questions about getting themselves kind of acquainted with these products. And then also being able to identify these gradients in speed. That's kind of the last thing that forecasters talked about in terms of display. So when looking at different environments based upon their deep layer shear, adjusting the maximum value on the speed then allowed for forecasters to more readily pick out those gradients and those contours within the OCTANE speed product. Additionally, when monitoring convection, using the ProbSevere version 3 time series tool that was frequently used throughout the test bed, especially when looking at increasing and decreasing trends. There's a storm up here in the upper right-hand corner that I've circled here in red. And this forecaster did have a warning out on the storm, but then decided due to the decreasing probabilities here to end that warning earlier than what they anticipated as the storm was decreasing then in its severity potential. In really active environments as well, forecasters can also leverage ProbSevere V3 and the time series tools to help them triage storms and figure out which ones are increasing in their intensity, decreasing, and which ones that they need to look into further. And this forecaster pointed this out in their blog post, talking about how it helped them triage those storms that needed attention and which ones that they needed maybe make an adjustment to in their warning decisions. Additionally, there were some cases we actually had this year, which we haven't had before, of these data dropout cases. So in some cases, like in this case here, you might notice that the local 88D radar was actually dropping a few of its inputs, and so that then is fed into MRMS and then into the ProbSevere V3 model. And so forecasters were able to understand the consistency in these data and how they compare with ProbSevere version 2. In terms of comparing the HER versus the RAP inputs between V2 and V3, there wasn't a lot of discussion that we had overall with that throughout the test bed. And so it's one of those kind of no news is good news, because forecasters didn't really even notice that it was there, especially in terms of those hourly adjustments, which they had noticed more often in previous years. When looking at DSS messaging with ProbSevere LightningCast, this was the most commonly used product, and forecasters relied on this heavily throughout the test bed, whether it was using the probability contours in AWIPS or using the web-based time series tool. We had the ability as well to take our mock DSS events and drop a point on there, and working with the ProbSevere developers, they then provided special time series for the forecasters to use each day. So forecasters use the LightningCast probabilities for initiation and the advection of those probabilities, and being able to then communicate those to their partners, to the general public. And so you can see an example of that in a graphic that a forecaster made down here in the bottom right-hand corner. And they're looking at initiation behind some storms that had already moved through earlier in the day. So looking at some initial redevelopment. And so forecasters also talked about within the test bed, needing to find useful thresholds. So oftentimes with initiation, using lower thresholds, and with advection, maybe using higher thresholds there as well. The case here on the left is a really good one, where a forecaster was talking about as storms were moving towards their DSS event, that was a pretty vulnerable setup. They provided about 35 minutes of lead time based upon what the information that they provided from ProbSevere LightningCast, and where they set their probability thresholds to then notify them of the lightning hazard that was incoming. So a few takeaways from the experiment here, not everything, but just kind of the big ones that we can think of and that I've talked about today. When looking back on NUCAPS forecast, forecasters were looking to really explore the utility of these data, especially in the half-hourly sense, so more frequent updates. Forecasters also expressed a desire for more data quality fields as well, to be able to know how much they should lean on those products and when. OCTANE, with its cloud top winds and motions and directions fields, were useful for identifying those cloud top divergence signatures, especially related to initiation, updraft trends, and mesoanalysis. Additional applications, I didn't mention them all too much, but mesoscale boundaries were able to be identified, splitting emerging cells could be observed, along with those above annual cirrus plumes. When looking at the PHS model, Forecasters again used that in a mesoscale analysis facet, but also wanted to see how the model's DA scheme adds value when compared to a control run or with similar cams, looking at products that expand upon that utility. And that was a recommendation that came out of the test bed. From ProbSevere LightningCast, the time series web tool was well received by the forecasters, especially in terms of using for DSS events. And that when using LightningCast, making sure that caveats with that in terms of training for those model limitations, such as that dense cirrus, are considered. And then lastly, with ProbSevere version 3, using that time series tool to help aid the forecasters in warning decisions, along with maintaining situational awareness when you have lots of convection ongoing and a number of features to look at. So aiding in those decisions, but then also staying aware of the whole picture, especially when things are quite active. Now, to wrap up here, I do want to make a few quick comments about the in-person and virtual experiments and how those were conducted this year, and some of the things we noticed during the testbed this year, since we did a little bit of both. The time in operations is very valuable, especially within our testbed. We only get 3 weeks, and so having longer events that we could run in person, because we had the forecasters there for a full day and didn't have to worry as much about screen fatigue as we would in the virtual environment, provided longer duration events, more discussions with the forecasters. We could have discussions between the different forecaster groups throughout the day. It was more seamless to move between the groups and have these kind of larger discussions. And this ultimately provided a greater depth of the evaluation this year. Flexibility was also built into the in-person schedule, as we don't really do that with the virtual schedule, as that can be more difficult for forecasters to do. But that then allowed us to target the best timing for convection each day. Forecasters also just had more time to test and break and create things within the test bed, to try out the product, to do more things with them, to gain a better depth of knowledge of each of the products. And then lastly, another thing that happened this last year was a return from the Warning Decision Training Division of the Tales from the Testbed webinar. So we coordinated with WDTD and were able to bring that back for the in-person week. We thought that was a good decision to make, and forecasters seem to really enjoy being able to directly share their perspective from that. And that's available actually on the WDTD YouTube channel if you would like to see that recorded presentation and hear directly from the forecasters. Developers and forecasters really like the in-person experiment, and it's something that we're looking to continue, but they found it was quite vital, as this developer mentioned in their end of testbed survey. Now, with plans for this coming year, as we now turn the calendar over to the next year, but we're looking to have our testbed take place again in that mid to late spring timeframe, looking at doing 2 in-person weeks now and 1 virtual week. And so we're kind of flipping the format from what we did this last year, exploring the use of archive cases. If that way we have days where we have just nothing really going on, we can at least show forecasters something and give them something to look at, especially earlier in the week. So if you are interested in maybe participating in this upcoming testbed, I know the details right now are scant, but more will come out with time. For forecasters, a call for forecasters will be coming out within about the next month or so. So you can make sure to check the HWP webpage online on the NSSL website, and you can find more info there. You'll see a forecaster opportunities link on the right side of the homepage there, and you can find information about those call for forecasters. If you're a developer and you have a product and you would like that is satellite based and you would like to demonstrate that, please contact me. My email is listed there. A call for products should be coming out within the next 2 to 3 weeks, and then we try to distribute that as widely as we can. But if you email me, I could definitely make sure to get that to you. If you've seen from this last year and you want to learn even more about this last year's HWT, the full report, everything that was written, it's quite an extensive report, is available on the NOAA Institutional Repository, and the DOI is then linked there in the bottom left. Wrapping up here really quick, acknowledgements. This doesn't happen without so many other people besides just myself. I'm kind of up in the front, kind of just conducting people and where to go. Everybody else is what I kind of think of as making the music in those cases. And so The GOES-R and JPSS programs, along with CIWRO, NSSL, and SBC, providing their overarching support of the testbed. Jonathan Madden and Justin Monroe here with SIMS and NSSL. Each year they've done a fantastic job setting up our cloud AWIPS and getting that ready so we can run this both in person and virtually, and it's pretty much seamless. And they do a really great job of being able to expand our capabilities within the testbed. Elisa Bates and Jessica Blair from WDTD assisted with details from the testbed. And then also a huge thank you to our product development team for bringing in product, our forecasters who devoted their time to making this happen, along with our observers and visiting scientists as well, who brought in their additional perspectives and expertise into the testbed. So thank you all so much for attending and this talk, and I'm excited to share this as we go into now this new year and a new testbed that's coming up here in May and June. But I'd be happy to take any questions, and I'll throw the mic back over to the host.
Okay, well, thank you, Kevin. This is Ross, and we really appreciate that. Was a very comprehensive overview of HWT 2023, and we really appreciate that, and really appreciate all the effort you all put in down there to pull that off and to really put these emerging products through their paces. I know that's a lot of work, especially getting back into doing it in person again. So yeah, definitely kudos to all you down there. Remind everyone we have a little under 10 minutes left to get a little Q&A and discussion going here with Kevin. So I'll whip through a couple announcements that I need to make. If you're gonna invite all folks online, field forecast offices, regional headquarters, everyone, if you have a question for Kevin, please get that into the chat now. Also, please make sure, as Jordan mentioned, to have your full name indicated if you're posting something in the chat. Also, Emily Maddox is going to be posting a link in the chat that will lead to a short feedback form. So feedback on today's HWT or on today's SBC session is most welcome. And so if you're so inclined, the link is in the chat there now. And coming up a week from today, so on Thursday, January 18th, at the usual time for these SBC seminars, we will have Tim Schmidt, who is the GOES-R Algorithm Working Group Imagery Lead, and he is going to discuss, the title of his presentation is A GOES View of 2023 and a Glimpse into 2024. So knowing what Tim usually does, I'm sure there's going to be some really interesting imagery from 2023 and the various big events, and also some insights as we look ahead as well. So be sure to come back at the same time next week. And also be sure to contact Kashad Bowman or Emily Maddox if you have any questions about the SBC seminars or any questions regarding configuration of satellite products. So yeah, we're going to hop into the discussion now. I can kind of throw out a first question here for you, Kevin. You know, there's obviously a lot of emerging products that are out there. So a thought that I had was wondering how you all make the determination and whittle that down to the 5 specific products that you're going to focus on. For example, in this past year's HWT, how do you go about that process?
Yeah, that's a great question. And it's something that we've actually adjusted this last year and implemented a more formalized process for getting the developers into the HWT. And so we've created an applications process that's a bit more streamlined and formalized from previous years. And so forecasters fill out an application and they provide what their product does. They provide kind of a very short kind of what science questions they would like to answer with the HWT. We also ask developers that are returning from previous years in the testbed to tell us what's new about the product this year. Why do you want to test with us again? What's the additional value that doing kind of repeat evaluations but with different configurations and setups would provide to you? We then take this, and I have a small committee that I create each year from research scientists here within NSSL, SBC, and CIWRO, and provide their feedback and input on the applications. And from there, We then make recommendations of what the developers can do to adjust maybe their scope. Maybe the product could be tested in a different test bed within the HWT. One of the things that we really strive for, though, is that we really don't want to turn people away if we don't have to. So we look at adjusting the scope or the location of products depending on what they're looking at within the test bed. This last year, we had 5 that applied that all were well within the scope of the satellite HWT, and we felt that we could test them effectively. And so we actually made pretty minimal changes on that end, and we had some really nice ideas that came out of that process. So we formalized it. We really are asking the developers now to show where they're adding value each year to their products and what's being put in the test bed, so we can then best allocate and use the resources that we have here. It's kind of a long-winded answer, but yes, we have the application process, and we then are able to make recommendations for the forecasters to help us refine how we're testing each product every year.
Okay, yeah, that sounds like a great enhancement to the process for this past year. Okay, we do now have a question from Michael Pavlonis in the chat. Can you talk about what comes after a successful evaluation of a high TRL product in the HWT?
Yeah, so after an evaluation, really where my position sits is to take what those forecasters are saying, whether it's with the data or with blog posts, and make sure that's communicated, especially through that final report. That then gets passed on to those within the GOES-R program, JPSS, along with Weather Service, and they're then able to, based upon the feedback that's provided and a number of other factors, of course, that go into the product, since we, of course, can't put everything into operations all at once. We only have so much space and so much room, and forecasters can only look at so much at one time. Then the determinations are then made of what can then be implemented into operations. And so I'm not as adept in those details of how that implementation process carries out. But we have seen, especially in cases, one example is ProbSevere LightningCast is a product that is being accelerated into operations, and the feedback from the testbed and all of our use cases and DSS samples were able to provide a really strong backing when those recommendations were made. So hopefully that answers your question.
Okay, yeah, thanks, Kevin. Yeah, Mike said thank you. So yeah, not seeing any other questions in the chat at this point. We're getting to our 45 minutes past the hour, so I think it is time to hand it back to Jordan to wrap us up.
All right, thank you so much, Ross, and thank you, Kevin. As has already been mentioned, the Satellite Book Club continues in 2024 next week. I know I don't want to miss it. Tim Schmidt talking about GOES in 2023 should be great. Hope you'll be able to join us. In the meantime, remember my ask from the beginning, TowerSR PM version 24. Please make sure, if you can, that your office is progressing to install that. Would really appreciate it. In the meantime, if you have any other questions about the book club, anything the TowerS team can help with, Emily, Maddox, Kashad Bowman, please get in touch with us. And with that, we'll call it a wrap on the first Satellite Book Club of 2024. Thank you so much for being with us today. Thanks again, Kevin, and thanks again, Ross. See you next week, everybody.